Hi Math 2 Enhanced. This is our Unit 6. It's the third review, and it just covers a few items throughout lessons 1 through 14. So the first question gives us some transformation rules, and then for each rule, we're supposed to describe whether the transformation is a rigid motion, which type it would be. That means, is it a reflection? Is it a rotation? Is it a translation? Is it a dilation or none of those? So this first one, I know that it's a translation because of the +5. So this guy would be a rigid motion, and I know that he's a translation. For example, this one, xy goes to yx. You could do a sketch out to the side and kind of take a look at that. You actually did this on page 17 of our book, and also again on page 29 of our workbook. This was a reflection over the line y equals x. So this would be rigid, and it's a reflection. It's a reflection over the line y equals x. But the problem didn't ask for me to be that specific, So this is another one that we did a couple times in the workbook, and I wrote those pages in the answer key that's in the locker. And then this is the one that I know is neither. Some of us in the beginning thought that this might be a dilation because it was 2 times x, but since it's not also 2 times y, then it's not getting twice as big both vertically and horizontally, so it'll be distorted. There's an example of this on page 16 if you want to take a look at one that we did in class. So for number 2, in this one you're supposed to write the equation for the circle described. For a circle, we have the equation x minus h squared plus y minus k squared equals my radius squared. So in the second one, for instance, my h is my 4, this is my hk, and this is my radius. So I have x minus 4 squared plus y minus a -8, which would be y plus 8 squared, equals r squared. If I square the square root of 3, the square and the square root basically cancel each other out, and I just get 3. So how about the center and a point on the circle? Well, if I'm given the center and a point on the circle, what I'm not being told is the radius. I know the radius is the distance between this point and the center of my circle. So I'm going to use the distance formula. It's on that formula sheet that is in the locker. I don't have it handy right now, but if you look in the locker, there's a handy dandy formula sheet you could print out and have to use. So it's a difference in my x values. In this case, I'm going to do 1 minus 6 squared. Doesn't really matter which one you start with because you're squaring it. Plus the difference in my y values, that's -4 minus 2 squared. It looks like my distance then would be, this is what, -5 squared, plus, and this would be what, -6 squared. So that's giving me the square root of 25 plus 36. What is that, 61? So this is what the distance is between the center and this point. So my radius is the square root of 61. I don't really need to find that value on my calculator. I don't really need to know what the radius is because in my formula, if you remember, it's the radius squared. So really, if this is what my radius is equal to, like up above, then really r squared is, if I square the square root of 61, the square and the square root cancel, and so my radius squared would be 61. So my equation would be x minus 1 squared plus y plus 4 squared equals then my radius squared, which would be 61. And then how about a circle with this diameter? So this is a problem that if you graph it, you would see that the diameter is a horizontal line, which makes this problem a little easier to work with. So if I graph -2, 4, he's right here. And if I graph 6, 4, 1, 2, 3, 4, 5, 6, 4, it's right here. So this horizontal line I just drew between 6, 4 and -2, 4 is my diameter. So to do this problem, you need to find two things. step one, the first thing you need to figure out is what the radius is, the length of the radius. So if you know the total length of the diameter from -2 all the way over to 6, you can then find my radius. Once you know the length of your radius, step 4 is that you're going to need to know the center. Well, the center is in the middle of my diameter. So for example, if my diameter is this 8 units long, that makes my radius 4. So 4 units to the left of 6, 4, or 4 units to the right of -2, 4 would be the location of my center. Once I have my radius and once I have my center, I can write my equation. So for number 3, I'm supposed to pick out which one of these are perfect square trinomials. So if you remember, a perfect square trinomial is something that I can factor into a binomial squared. And the shortcut way that we did that in the classroom was I would look, for example, let's look at B. I could take the square root of the first term, which would be y, and the square root of the last term, which would be 5, and I would get my sign from my middle term. And I would say that this guy was a perfect square trinomial, and he factors perfectly into y plus 5 squared. Y being the square root of my first term, 5 being the square root of my last term, and the sign coming from my middle term. So in this particular problem, I would know that he's not a perfect square trinomial because my square root of my last term is not a number that when I double it, I'm going to get the -10 in the middle. So that's something to think about with those problems. Number 6. This was when we first did a problem that we had to learn how to complete the square twice in this problem. And so let's take a look at this problem. Step 1 is that we get the x terms together and we leave a space. We group our y terms together and we leave a space. And we move our constant term, which is the +10, we subtract it from both sides and put it on the other side, which gives me a -10. So when we did this problem, we have to determine what our c is, the number that makes this a perfect square trinomial. We had to do our b term divided by 2 and square it to get what my c term is. So 8 is my b term because this is ax squared plus bx plus c. So we would take our 8 divided by 2 and we'd square it. 4 squared would be 16, and I'd be adding 16. I just added 16 to the left side of my equation from nowhere. I created a perfect square trinomial. If I'm going to add 16 to the left side of my equation, I better add 16 to the right side of my equation. It wasn't there before. I just put it there, so I need to put it on both sides to keep my equation equal. Same thing over here. My b term is -4. So -4 divided by 2 squared is -2 squared is 4. So I'm going to add 4 to make that a perfect square trinomial. And if I add 4 to the left side, I also have to add 4 over here to the right side. So cleaning this up, my step 3, this is a perfect square trinomial. It perfectly factors into x plus 4 squared. And I can find that 2 different ways. The shortest way is the number that goes inside my binomial is always my middle step. Also, going back up to number 3, the square root of my first term is x, the square root of my c term is 4, and the sign in the middle is plus. So doing the same thing for my y trinomial, this would be y minus 2 squared. And then cleaning up this side, 16 plus 4 is 20, minus 10 would give me 10. So I can see that my center is -4, 2, and my radius is equal to the square root of 10. And you could write that as a decimal if you wanted to as well. Okay, ladies and gentlemen. So the next page is asking me to write the equation of a parabola given the focus and the directrix. So as a reminder, you have to remember that the equation for a parabola is x minus h squared plus y minus k squared equals y. Oh, I'm supposed to use AB here. Sorry. AB. It's been a long day. So my focus is AB. And my directrix is y equals k. So anyways, back to this. Sorry about that. Y minus k squared. So I'm going to plug in my -2 and 6 and plug in my 4, and I'll get the equation of my parabola. So x minus the -2 would be x plus 2 squared plus y minus 6 squared equals y minus 4 squared. That is an equation of a parabola. What that is, though, is not a very useful equation. We a lot of times think of the vertex form of the parabola as a much more user-friendly equation because I can graph easily from it. That was what we did last year in algebra. And the vertex form, just to remind you, was y equals, and that was a, x minus h squared plus k. And so this h and k and this a have nothing to do with this a, b, and k over here. They're different numbers. So they're just reused in the two different types of formulas, but they're not related to each other. So in order to rewrite this answer in this form, I basically have to do a lot of algebra. So I'm going to leave this x term alone because if you notice in my vertex form, I do have an x term squared. So I'm now going to use my algebra skills to multiply out my two y terms. That's either box method or FOIL or however you do that. So I have x plus 2 squared plus y squared minus 12y plus 36 equals y squared minus 8y plus 16. So when you do this, conveniently my squared terms always cancel. And I now have to solve for y. I have to get y by itself on one side of the equation. You can move it left or right, it doesn't really matter. I tend to like to leave the x squared over here and move my y terms to the right. But again, it's algebra, you can do it either direction. So I'm going to add 12y to both sides. And that would give me, these guys would cancel. So I would get x plus 2 squared plus 36 equals, and then -8y plus 12y are like terms. When I combine them, I get 4y, and I still have my plus 16. So again, to isolate y, I'm going to subtract 16 from both sides. I get x plus 2 squared. My plus 20 equals 4y. My very last step is to divide both sides by 4. And when I do that, I divide every term on both sides by 4. Remember, we don't write this as a binomial divided by 4. Instead, we multiply by the reciprocal, which is 1 over 4. Plus, what is this? 5, and that cancels to y. So my answer for part B is y equals 1/4 x plus 2 squared plus 5. Lots of fun work there. Okay, ladies and gentlemen, so for the next one, to write the equation of these lines, I need to know the slope and a point on the line. So I'm going to use my point slope equation, which was y minus k equals my slope times x minus h, where hk is a point, like 5, 6, for instance, and m is my slope, the 2/3. So for the first one, I literally am just plugging them in. So let's take a look at the second one. This is the slope of the line. It says I want to write an equation of a line that's parallel to this line. So I know that if they're parallel, they have the same slope, and I know it passes through this point. So again, I'm just going to enter those into my equation. So then on C, it says it's perpendicular to this line and passes through this point. In order for two lines to be perpendicular, their slopes have to be opposite reciprocals. So my perpendicular slope in this case would be 3 over 2, and opposite would mean that's positive 3 over 2, and it passes through this point. So putting it in my point slope form, I'd have y minus 2 equals 3/2 times x minus 0 in this case. And you could just drop the x minus 0 and write it as 3/2 x if you wanted to. Okay, ladies and gentlemen, so for number 12, this problem I think is like practice 1 in practice 12, number 1, sorry, in practice 12. So it wants me to determine for each of these equations if the graph of this equation is parallel to the line shown, perpendicular to the line shown, or it's neither. So first of all, let's determine the slope of this line. The slope of this line looks to be a positive 1/5. So my slope would be 1/5. So any line that has a slope of 1/5 would be parallel to this line. My perpendicular slope would be -5/1 or -5. So any line that has a slope of -5 would be perpendicular, and a line that has another kind of slope would be neither one of those. So looking down through here on all of these problems, I can quickly see what my slope is, and I can make a decision whether it's parallel, perpendicular, or neither. In this final problem, if you just go ahead and subtract the 5x over, you again have it in a form that you can quickly see what the slope is to make that determination. And my last problem, it gives me the equation of a circle shown. My circle's center is at 5, -1. And the radius of my circle is 5 units, 5 to the right, 5 to the left, 5 up, and 5 down. It asked me to graph the line y equals x minus 5. So my slope is 1/1, and my y-intercept is 5. So let's plot my y-intercept and keep working over 1, 1. My slope is 1, 1 for this one, and I can draw this line in neatly. So it asks me, how many points does the line intersect the circle? It looks like it intersects at 2 places. Looks to me like it intersects here at, what is that, 8, 3, and also down here at 1, -4. So then on question 4, it says, find and verify at least one point where the circle and line intersect. So you could do this multiple ways, but one of the ways that we were using in class to see if a point was on a circle or on a parabola or on the line is we would plug the point into the equation and we would see if it makes the equation true. So let's practice that skill here. Let's verify that 1, -4 is for sure on the circle, because I can tell that it's on the line. It was one of my points. So we're going to take 1, -4 and plug it into my circle equation. So I have 1 minus 5 squared plus -4 plus 1 squared. And I'm trying to see if that's equal to 25. So this would give me -4 squared plus -3 squared. And I'm trying to see if that's 25. So 16 plus 9, which we see a lot, is indeed equal to 25. So yes, I can verify that 1, -4 is on the line, because it was one of the line points I plotted, and this verified that it is on the circle. And you can do the same work for 8, 3. Thank you very much.